Simplifying radicals, remember with the exponents on the variables, they need to be even for it to be perfect. So I always set up my two radicals. M to the fifth, we're going to have to make it m to the fourth, and then the fifth one goes in the leftovers. N to the third, we can make n squared, and then the third one goes in the leftovers. Square root of m to the fourth, you just divide the exponent by 2. So it'd be m to the second, n to the first, and then you got your root m n. All right, now we're going to throw a number in front of it. 32 is 16 times 2. So with the 16, I'm going to put all my perfect stuff. So x to the fourth, that's fine. Y to the third, no dice. So we can put 2 there. 1 goes in the leftovers. Square root of 16 is 4. Square root of x to the fourth is x to the second. And y to the first. Root 2y. 200 is 100 times 2. A squared is perfect. B is not. So we just leave it in the leftovers. Square root of 100 is 10. Square root of a squared is a. And you have your root 2b. All right. Fractions, remember you can't have radicals in the denominator. Sometimes they're listed as one thing. Remember that means the same as if they are listed separately. These mean the exact same thing, so it doesn't matter how you think of it. Now, anytime I have a perfect square in the denominator, I just handle that right away. The square root of 25 is 5. Are there any perfect squares in 17? No. And it's fine to have a radical in the numerator, just not the denominator. So root 7 over root 16, just take the square root of the 16 right away, which is 4. So we have root 7 over 4. 7 does not have any perfect squares in it, so we're all done. All right, root 6 over root 49. 49 is a perfect square, it's 7. So we're left with root 6 over regular 7. $125, break it up. 125 is 25 times 5. Square root of the square root of 25 is 5. So we have 5 root 5. 4,000. I see it ends in double zeros, so I would probably go with 100 times 40 initially. The square root of 100 is 10, but 40 still has a perfect square in it, and it's 4. So I would make that 4 times 10. Square root of 4 is 2, so 10 times 2 root 10. And then we can multiply our regular numbers. 10 times 2 is 20. Root 10. All right, 216. That might be a perfect square. 108, 4. All right, I know 36 goes in there, so we'll start with that. 36 times, I don't know, 216 divided by 36. 6. All right. A squared is perfect. B squared is perfect. Square root of 36 is 6. Square root of a squared is a. Square root of b squared is b. You have your root 6 hanging out at the end. 320, r squared, s squared. 320, I know 64 goes in there 5 times. So 64 times 5. R squared is perfect. S squared is perfect. Square root of 64 is 8. Square root of r squared is r. Square root of s squared is s. Root 5. We could get some of these done. Root 32 minus root 8. They're not perfect squares, but they have them. 32 is 16 times 2. 8 is 4 times 2. So square root of 16 is 4, 4 root 2. Square root of 4 is 2, 2 root 2. Now they are both root 2's. 4 minus 2 is 2, root 2.